equation, make sure you look at the summary. Remember, when it is cos x equal to 1, 0, or -1, stop. You have to use the graph of x, cos x. If it's sin x equal to 1, 0, -1, you have to use the graph of sin x. If it's 0 or tan x equal to 0, cot x equal to 0, use the ratio sine over cos or cos over sine. Any other equations using the related angle and the quadrant approach. So now we're going to continue with other types. We're going to look at part B. Now, what if there are two different things, like sin x and cos x in one equation? So what you could do is just divide both equations by cos x. Like that. And that cos x gets cancelled, gives you √3 tan x equal to 1. And then we continue. And then tan x equal to 1 over √3. And then we do x equal to, now once you got the tan, that becomes a normal equation. Use a quadrant. When is tan x positive? Positive in the first or third. Yep, good. And then we find the related angle. Related is tan inverse of 1 over √3. Use your calculator. But if you memorize the table, you can work out without a calculator. Tan inverse of 1 over √3. Work out 30 degrees. Well done. So put 30 there in the first quadrant, 30 there in the third quadrant. Then you can find x. Alright, let's find x. So how do we find x? In the first quadrant, it's equal to the related angle. In the third quadrant, you do 180 plus 30. So the answer is 30, 210. Actually, I made a mistake. I can't do it this way. I have to watch out for the domain. Actually, not domain. You have to watch out for this number. X cannot be bigger than 180. So I can't have 210. So what I need to do is to go backwards. So I have to go back. So I do going back like this. So instead, you do negative 180 minus 30. So that gives you negative 150 is the other answer. Alright, done. Alright, okay, any question? Alright, good. Alright, and then we'll do part C. Okay, let's do this. Okay, next one. Cos 30 plus x equal to half. So for this one, you still do the same thing. Now, when there's an angle changes, 30 plus x, you start off with x is between negative 180 and 180. And what you need to do, because there's a plus 30 there, that could affect your answer. So just add 30 to both. And you end up getting negative 150 between x plus 30 between 210. So that tells you the range of answers that we could accept. Okay, so we'll just write this down first. Alright, the first step is to look at the quadrant. It's in the which quadrant if cos x is positive? It's in the first or fourth quadrant, right? Half is positive. And then you find the related angle. Related is equal to cos inverse of half. And cos inverse of half using a calculator, or if you use the exact value, is 60. Label 60. And once you do that, you can then start to find x. Now remember, you're not finding x first, you're finding 30 plus x first. 30 plus x equal. 30 plus x equal to 60 in the first quadrant. But in the fourth quadrant, I cannot go like this. I can't go like this because that will be more than 210. So I can't do that. So what do? We go backwards. We go backwards. So how do I get backwards? We'll go that way. So it'll be negative 60. Yeah. Okay, that's it. I don't think we can go any other ways. So your final answer will be, now to find x, you have to subtract both answers by 30. So you're going to subtract by 30 on both sides. So you end up getting 30, negative 90. Yeah, like that. Okay, good. Any question? If it's half, you mean if the line is on the other side? Yeah, because it's like solving this, like half, there's a number there, see? 3/4, half, it's a ratio. Yeah, not angle. Alright, hopefully all makes sense. Alright, let's move on. You have to stop talking now. Shh. Shh. Alright, we need to do another one. Next one. Okay, whenever you have a compound angle, make sure you do this first. X is between 180 and negative 180. And you have to multiply each number by 2. Like that. Which become negative 360. 2x, 360. So 2x can be between these two numbers. So on page 24. And then to solve it, we first have to get rid of the root 2. Sine 2x equal to 1 over root 2. Like that. And then you look at the quadrant. Which quadrant is sign positive? In the first or second. And find the related. Again, if you know your exact value, that will make it faster. Sine inverse of 1 on root 2. What would that be? 60. Okay. Or 45, sorry. 45. Put 45 there. Alright? Then we have to go find the actual angle. Now remember, we're finding 2x first. That's why you need to know how far 2x can be. So 2x. Now for 2x, what we could do is going to be 2x. Okay, so we have to write down the first quadrant. First quadrant is 45. On the next quadrant, you do 180 minus 45. Right? But there's more because you can go negative angle. How do I go negative angle? You go clockwise. So that means it's going to be negative in bracket 180 plus 45. And you can go around in a bigger arc all the way there. Because it can be as low as negative 360. So it will be negative in bracket 360 minus 45. You just get a negative angle. So your final answer will be, not the final answer, yes, 45, 135, negative 225, negative 315. And then we have to take away the 2. So after that, we divide everything by 2. That's a poor choice. They are all not divisible. Should have used a different one. Alright, anyway, you get a decimal for each of these. So use your calculator. I could do this, the first one in my head, 22.5. The other one, let me see if I could do that. Too hard, I'll use a calculator. So the next one, you just go 135 divided by 2, 67.5. The next one, I could do without a calculator, 112.5. And the last one, I need the calculator, 157.5. Yeah, like that. You will notice your final answer will be between negative 180 and 180, as expected. Alright, good. Any question? These are the hard types you could get in the test, so make sure you learn this. And yeah, okay, after this we're going to do some graph as well. We have to do more graph. We have to do the tan graph. We haven't done the tan graph, so we're going to do the tan graph. And as well as that, we should also look at the complementary one, the cosec, the sec, and the cot. Are these tested? I think you could, so we should do them. It's in the textbook. We're going to do the tan graph, so what do? Use the calculator. So going back here, tan 0 equal 0. Tan 30. Tan 30, what do? 30, put a 3 there. Get 0.5, or we'll just 0.6 to make it easy. 60 degree, 60, you get 1.73 or just 1.7. 90, I think you get, what do you think 90 will be? Again? 0.6? No, 90. Why is it stuck? Okay, there it is. 90. Error. Remember, boundary angle, you get undefined. Yeah? Because you get 0 in the denominator when you use the calculation. And then do 180, 120. You get negative 1.7. And then keep doing until you get the full graph. And whenever you get error, you get a cross. And we'll see what the cross is in a minute. Alright, try to finish that. I will just pause for a while to see chord. So this, okay, next one is negative 0.6. And then you get 0, negative 0.6. Hang on, would it be negative? Oh no, it become positive again. Let me think. Yeah, become positive again. So you should get 0, 0.6, 1.7, and then this cross, and then you get I think I made some mistake. No, I didn't. Alright, yep. And then we'll plot the points. Now, okay, we'll continue. We're going to now, what do I do at the crosses? We draw what we call the asymptotes. Hopefully remember this term last year, asymptotes. So tan graphs are a bit tricky, it has got asymptotes. Okay, after this we're going to plot the points. So starting from 0.6, 1.7, and then goes to infinity. 0.6, like that. Right, done. So that's the graph of tan. So you just remember there are asymptotes, and then you have this that keep repeating every 180 degrees. So asymptote means it never touches, it goes to infinity, it just goes higher and higher. Goes up very quickly. Alright, good. Alright, let's do some. Let's calculate some cot value. So if you go like this, calculator. So if you do 1 divided by tan 0, you should get undefined because you can't divide 0 in the denominator. And the next one, 1 over tan 30, gives you 1.7. 1.7, tan cot 60, 0.6. Actually, that may not be the best way. There's another way to calculate cot. I just realized, which can be helpful. I think that's not a good way to do cot. But it is a way, but there's another way, which I believe are better. You just go tan 90 minus x. So what I do is, so if I want to do the next one, for example, cot 90 will be tan 90 minus 90, which you will get 0. So that should be 0. If you do 1 over tan, you will get, if you do 1 divided by tan 90, that gives you an error, right? Because tan 90 is an error, so you can't do that. So it's better to do 90. So the next one, so if I want to do tan cot 120, do tan 90 minus 120, like that. Okay, good. So you get negative 0.57 or negative 0.6, and keep going. So the next one will be 150, 150, negative 1.7, and you just keep going. I think 180 you get error. 180 you get error. Okay, error. Right, good, and then you just keep going. Alright, keep going, you get the next one, which is 1.7, 0.6, 0, negative 0.6, negative 1.7, and then I think you get that. Now, remember the formula? That's the formula, the complementary formula. Tan 90 minus theta. Okay, remember that formula. That's complementary. And there's one for sine as well. Sine theta equal to cos 90 minus theta. I'm just using this formula we used before. Alright, okay. So now we're going to draw it. Every time you see a cross, it's an asymptote. So put dotted line, dotted line, dotted line, and then you just draw it. So 1.7, 0.6, 0, 0.6, negative 0.6, negative 1.7, goes down like this. Ooh, like that. Okay. And the next one, you keep going. Do the same thing. Actually, I got it wrong. Okay, good. Like that. Okay, so you see, it's very similar to the tan graph, isn't it? Except that it is going in a different direction. This one's going upward. It's the same shape, but this one's going downward. The tan and the cot. Yep, okay, good. Any question? The next 2 sec and cosec, I'll leave you to do at home. We'll just go through the next lesson because I want to do something else today. Alright, so cot and cosec and sec, you can do that at home. And then, so just write on the top homework. And then you just finish it. Or you can finish it today in class. So just remind you to do that. You just do 1 over sine. And this one, you do 1 over cos. Okay? And just draw these two, the reciprocal of sine and cos. That's why I include a sine graph and a cos graph. And you'll see the connection between them when you draw the graph. We'll discuss that next lesson. Alright, today we're going to learn a new identity. That's the last identity that you're going to learn in trigonometry. That's the last identity. The Pythagorean identities. Okay? Alright. Yes? Because this one, they are not related by complement. So cosec 90 minus x equal to sec. But they're not related, whereas the tan and cot are related, not just reciprocal, also related by the complement. But the sine and cos cannot be done using the 90 minus because they are different formula. So you have to use 1 over sine. There's no other choice. Whereas the other one, it doesn't matter whether you use this or that. That gives you the same answer, except at the 0. You wouldn't work for this formula. So you have to use this one. Okay? Alright, let's move on. Actually, I should rub this off. Oh yeah, actually I'll leave it there. Okay, let's look at the last identity you learned in this course for trigonometry. And there won't be new ones in year 12, so you make sure you remember these for year 12 as well. Let's calculate the first one. Hopefully remember the exact value. What's sine 30? What's sine 30? Half. What's cos 30? Root 3 over 2. And if I square both, let's see what we get. A quarter plus 3/4. What's that equal to? 1. Maybe. Well, what's sine 90? 1, right? What's cos 30? Cos 90? 0. You still get 1. Does that always work? Would it work for the next one? You could try with the calculator or by hand. This one you can do it by hand. Next one you can't do it by hand. You have to do it with calculator. So this one you just go in the second quadrant, related angle 60. So it will be positive sine 60, but negative cos 60, right? But you square it, which become positive. So root 3 over 2 all square. That will be negative half all square. But if you square negative, you still get a positive. You still get 3 over 4, a quarter, 1. Alright, the last one, use a calculator. You just go sine in brackets, brackets sine 200 square. Actually, you don't need that many brackets. Just put a square here. Get rid of the first bracket. Will be enough. Okay. Go back. Plus cos 200 close bracket square. The two angles has to be the same. You get 1. Okay, so it's 1. Calculator. Alright, so we learned a new formula that if you square the sine, square the cos, you get 1. And the question is, why is it so? And why is it called the Pythagorean identity? It's related to Pythagoras. Let's see why it is related to Pythagoras. So let's prove it. There are 2 ways. The first way is a better way because it actually uses the Pythagoras theorem. So let's draw a right angle triangle and put a theta there. Unlike always, we're going to have an A, have a B, have a C. Well, let's work out what sine theta equal to. Opposite over hypotenuse. So opposite over hypotenuse in this triangle is B over C. Let's work out what cos theta is. Adjacent over hypotenuse, A over C. And let's square them. If you square them, you square the fraction B over C, square the fraction A over C. Right? If we square the first one, you get B squared on C squared, A squared on C squared. And what do they have? They have the same denominator. So we can write that over C squared. Alright. And then we look at the triangle. Why is it Pythagoras? What does Pythagoras say about this triangle? A squared plus B squared is C squared. So this is C squared, right? And what's C squared over C squared? So that's why it's 1. So this is now called the Pythagorean identity. This identity comes from Pythagoras theorem. Alright, so you need to memorize the rule. You don't need to know the proof for the exam. You just need to remember that rule. And fortunately, it is on the formula sheet. Oh, I haven't got it open. Let's close that. Close. Let's open a formula sheet. I've got it there. Reference sheet. Let's go back here. That's one way to prove it. Method 1. Method 1. There's another way to prove, which is much quicker. Method 1. There's a method 2. Hopefully it's loading. So if you look at your formula sheet, it's going to come out soon. No. Okay. Let's look at method 2. By the time I write this, it will come out. Method 2 is much quicker. It didn't come out. Formula sheet. It's very slow. Alright, method 2. Method 2 requires you to draw a circle of radius 1. Still doesn't. Oh, yep. It's ready. Okay, now, formula sheet. Can you see that one there? Now you know where that comes from. This one here. Sine squared plus cos squared 1. So it's complete. They give you this one. Sine squared plus cos squared. Alright, so that's all they give you. There's another one you have to learn, but I will show you in a minute. Okay. Alright, now, remember this. We have a theta here, and we get a point, right? Now, the point is x comma y, right? And we learn the new definition is that x equal to what? Cos theta, right? Y equal sine theta. Now, hopefully, you remember from last year the equation of a circle. What's the equation of a circle of radius 1? If you remember, that's very good. What's the equation of a circle? X squared plus y squared equal to r squared, right? And what's the radius? 1. That's the equation of the circle. So what's x again? X is cos, right? Cos squared. Y is sine squared. That's it. That proof is not as amazing as the first because it uses the Pythagoras theorem. This one just uses the equation of circle. A little bit boring. But anyway, that's another proof. I think that's a better This will be more rigorous proof because that theta doesn't have to be in the first quadrant, could be in any quadrant. Whereas here, it's limited in the acute angle. But that has more meaningful, right? Okay, we're going to move on. Yep, okay. All right, quiet please. You've got enough space. Okay. Now, remember this first rule I just wrote down. Let's write it down again. Let's start with cos. Cos squared theta plus sine squared theta equal to 1. That's one formula on the formula sheet, but I prefer you to memorize another formula. Move the cos squared to the other side of the equation, you get this. That's another formula. First equation, second identity. You can get a third identity. Just rearrange and write 1 minus sine squared. You should remember all three. Right? So cos squared theta plus sine squared theta is 1. Or you can express sine squared theta in terms of cos squared, or express cos theta in terms of sine squared. So you've got three other. So this one gives rise to these two. And you should memorize them separately. So I'll write the word on the top, memorize. The pen's not working well. Alright, memorize? Okay, now there's actually more. There's one on tan and sec and cosec, everything. And that is, yes, you have to learn. But that's the last one. There's no more after this. I can promise you. If you do extension 1, there will be more, but since you're not in extension 1, that's the end of it, okay? So you can thank that you're not in extension 1, so you don't have to learn more of it. Okay, now, let's go back to the first one. Cos squared theta plus sine squared theta equal to 1. Let's divide every term by cos squared. Let's see what we get. Okay, what's cos squared over cos squared? Yep. Okay, what's cos over cos? 1, right? What's sine over cos? Tan. What's 1 over cos? Reciprocal cos? Sec squared. Another formula. Sorry, I forgot that I have to do this. I thought I'd just do the proof. Sorry. Tan squared theta plus sec squared theta. Let's start with the formula again. There's one more, that's the last one, I promise you. Alright, you need some sticky note, get a sticky note here. Alright, so you get cos squared theta plus sine. Yeah, you can. Alright. Pass it on. Sine squared theta equal to 1. I'm going to divide everything by sine squared. That will give you something else. Divide by sine squared. Now what's cos over sine? Cot. What's sine over sine? 1. What's 1 over sine? Cosec. But it's not hard to remember because the co match with the co, right? And the non-co match with non-co. So see the co with the co, and then the other one doesn't have a co. So that is so 5. Okay, so get a highlighter. This one. That's the final 5. And then we're going to summarize all the formulas on the next page. And then we'll do some questions. And then on Friday we'll do some revision. And we'll finish this booklet. And then we'll have a new booklet on trigonometry next term on sine rule, cosine rule. Okay. That's a plus. Yeah, no t, plus. So that's a 1 plus tan squared theta. That's cos squared theta plus 1. Yeah, plus. Okay, already, let's write them all on one page. We have a one-page fact sheet on all the trigonometric identity of your advanced course. One-page fact sheet on all one page. If you write them out 10 times, you will be able to remember them better. If you write them out 100 times, you will never forget them. Okay, yep. Yes, let's do them now. Yeah, like just the formula. I'm not including other things, just the formula. Let's start with the reciprocal identities. Is that still recording? Yep, good. All right, what's a reciprocal identity? Sec theta is 1 over cos. Cosec theta equal 1 over sine. Cot theta equal to 1 over tan. Just 3, right? We've got the two ratio identities. I could make it a little bit bigger. Okay, ratio. Actually, I could make it like this, page width. Okay. Next one is, what's sec? No. Next one is tan, which is sine over cos. And then cot is cos over sine. Put some bullet points. You don't have to. And then we met our new friend, Pythagorean identities. The first one, the most impressive one, the cos squared theta plus sine squared theta equal to 1. Thank you. That was really quick going around the room. Okay, that was quick. Okay, good. Next one is cos squared theta equal to 1 minus sine squared theta. And then sine squared theta equals to 1 minus cos squared theta. So the Pythagorean one all have squares in it, whereas the other one doesn't have squares. And remember the two of these, like 1 plus tan square equal to sec square. And the other one, 1 plus cos square equal to cosec. These are not hard because just remember the co match with the co. The formulas. Yep, I'll tell you which one. So the one on the formula sheet is, let me see. Okay, the one on the formula sheet is only this, and this. Only 5. Only 5. Only 5. Look, only 5. So you have to, so they only give you 5. Might as well memorize everything. Huh? No. 1, 2, 3, 4, 5. No cot. So you need to know the cot one by yourself. Okay, so only 5 are given. That's the only one? No, you need to know everything. Okay, let's continue. All right, complementary identities. Have to remember cos. The complementary one is sine 90 minus theta equal to cos, and cos 90 minus equal to sine, and then you got the sec 90 minus theta equal to cosec, and then cosec 90 minus theta give you sec, and then tan 90 minus theta equal to cot, and cot 90 minus theta equal to tan. So that's 6. So they're all the same. All right, I'll leave it here. Again, put some bullet points. That's okay. It's up to you. Almost. Oh no, not really. I want to do some maybe we'll leave that for next time. Or no, I want to do some. Actually, I don't know. Yeah, maybe I'll leave it next time. 1, 2, 3, 4, 5, 6. Yeah, next time then. All right, you just learned the formulas today. Hang on. All right, after you finish this, hang on. Okay, we've got one more. Angles of any magnitude. Yeah, good idea. We'll leave it on Friday. Make sure you come to school on Friday. Okay, angles of any magnitude. Okay, now, sine 180 minus theta equal to sine theta. Remember the one we learned about all station to central. you get negative cos, and then tan, you get negative tan. Remember these ones we did earlier? If you don't remember, go back to the older page. I'll tell you what page to look at. We did it on page 18. Page 18. Okay. All right. So you've got these ones, and we also have the one with the 180 plus. I will stop very soon. And then you get, they all have the same angle, but some are positive, some are negative. Just remember, this is like the third quadrant. This is like the second quadrant. So in the third quadrant, only tan is positive, the rest are negative. Right? Have a look at page 18. It will make more sense to you. And you also have the fourth quadrant, sine 360 minus theta, cos 360 minus theta, tan 360 minus theta, and that's like the fourth quadrant. Fourth. And in the fourth quadrant, only cos is positive. The rest are negative. And you also have a negative angle. That's also like the fourth. So you got sine negative theta, cos negative theta, tan negative theta. They are only cos is positive. The rest are negative. This is all the formulas that you need to know. Yeah, not the summary. I've got summary at the back. No, that's a summary, just the formula. Well, how many summary? We can do summary of all summaries soon. Well, we'll just summarize that section, and then we'll have a more summary of the whole topic, which will include other things, like how to solve trigonometric equation, how to find the exact value, how to find other things. Yeah, remember these stuff. Let's press stop.